So as I said in the last video of Python Basics episode 1, in this video we'll be looking at list, tuple, dictionaries and conditional structures like if-else and looping structures like while and for. Hi, Pushparaj here. Welcome to the AI Alley. So in this video of Python Basics episode 2, we'll be looking at the remaining data types of Python that are list, tuple and dictionary, and along with that I'll be covering looping structures and conditional structures. So let's start with the remaining data types. First we'll be looking at list. On the right hand side there is a couple of examples of list, and on the left hand side I am using the ideally, that is Python 3.6. I have explained all the details about this ideally in the last video, go check it out. So in Python, list is a data type in which you can store multiple types of data structures. So I'll create a list here. Similar to str, that is a string data type, list also has a class named list in Python, so we can't use that. So similar to string, list also supports indexing. So this is the 0th index of list 1, that is ABC. I have explained indexing in the last video. So we'll be going over slicing as well in list. Starting with 1, ending with 2. The stuff about slicing is also explained in the last video. What I'm doing here is I'm modifying the list at index 1, which was not possible in string. List is mutable and string and tuple are immutable. We'll be seeing tuple in a couple of minutes. So list 1 of 1, here the earlier value was 10, now it will be replaced with AB. And yes, list supports multiple types of data in it, so dynamically changes the data type of that index as well. So as we have seen in the last episode, we can concatenate two strings. So here we can also concatenate two lists into one. List 3 will have all the elements of list 1 and 2. And we can also duplicate the list using a constant and multiplication operator. It won't change the original list, but it will just modify and duplicate the elements in the list for display purpose. So that's it in the list. We'll be going over tuples. So tuple is basically similar data type like list. It holds multiple types of data inside it, but the slight change is tuple is declared as a circular bracket or parenthesis, and list has a square bracket. So I'll be declaring a tuple here. I'll be copying this and replacing the square bracket with circular. So tuple works as a type of set. If you know set from mathematics, set holds a set of given parameters into it. Similar type happens with tuple. And all the above operations that we did on the list, like indexing or slicing or concatenation of tuple, that is possible in tuple, so I won't be replicating it. Let's move to a dictionary. So important thing in dictionary is it also has a slight change in structure. It uses curly brackets instead of circular or list like square brackets. So, and main thing about dictionary is you have to define the dictionary or you have to map it with a key and value pair. So I will be using both of it here. We'll be defining a dictionary first. So key is a essential part of a dictionary which addresses or maps each of the values in the dictionary. So here I am declaring the values inside the dictionary. That is, key is 1 and key is 1 and the value of that key is alphabetical 1. So here you can see the dictionary dist1 has been mapped with two values, that is with the key value pair. Key is this integer variable and value is this. So the key is not necessarily to be integer. You can change it. You can have a different key as well, like name. Name will be the key and the value will be. So this name will be not replaced with any of this, but it will be concatenated at the end of the dictionary. So how is dictionary useful? Dictionary, you can map value pairs like name, address and phone number in a simultaneous structure, and if you have knowledge of which key is assigned to which value, you can easily access those values with the keys. This was done dynamically. If you want a predefined or pre-declared dictionary, you can do that as well by directly mapping while defining the dictionary. It too will have all the values that are mapped above. So does dictionary support indexing and slicing? The answer is no, because the key value pair, as I said earlier, has a very important role in it. So if we try to print means the second dictionary, that is dict2 of 1, it will not display the index 1. Instead it will print the value which has a key of 1. So if I change it here and try to print index 2, which is for us, index 2 is actually not here, but if I go with index 0 and try to print it, index 0 will be this whole element. It will not print because for us index 0 is this element, but for the dictionary there is no key available as as 0. So indexing is not possible, and because indexing is not possible, slicing is also not possible, because the whole slicing concept depends on the indexing. So how do we know that which keys are present in dictionary? So there is a special function with dictionary data type, which is the variable name dot keys will print you all the keys of that variable if we are not remembering any key, or we are misspelled any key. So this will be a list of keys that will be displayed using this dot keys function. Similarly, you can also print the set of values that are present in that dictionary. This dot values will give you a list of values in the dictionary. So we'll be saving this file as well. List, tuple, and dictionary. So here on the right hand side, I have a pre-coded file of if-else structure that will be representing all these operations, all this structure of if-else. So this is a basic if construction where you see a condition inside a circular bracket. So Python does not have a curly bracket or indentation style of curly brackets. So here we use a colon and indentation of, let's say, a tab, which defines the statement is inside that condition or inside that colon mark statement. So this is a traditional, means a simple if conditional structure, and let's run this. You can see that the value 10 is of the condition that is given inside the if structure. Let's move towards if else. If you are confused with what I am doing here with the triple quotes, this is triple quote commenting, which is done in Python to comment a whole block of code, and for a single statement you use hash. So we'll be using a if else condition, if else structure. So here the condition states that 25 needs to be the value inputted to make this statement true. So we'll input a false value and move to else part of that structure. Similar goes with if else ladder or elif ladder, as we say in Python. Just like in C or Java, you create a ladder of if and else statements with conditions, multiple conditions, and a single else at the end. So here elif is denoted as else if, which is done in Java or C. This is a traditional structure that we used in C or Java. but here we use elif. So let's run this. So the conditions are 5 and 20. I'll be directly falsifying all those conditions. So this is the else statement which is present at the end of all these multiple conditions. So that's for how you use if-else ladder or if-else conditions in Python. Moving towards the loop structure. The loop structure here in Python is similar to C or Java, only changes in the for loop. I'll be explaining that. Let's comment it out for a while. So while loop is the same as in Java or C++ or C. So here we give a condition and the inside statements are present, and so at the end we increment or decrement the variable that we have given in the condition above. So let's run this. So here again I am taking a dynamic input. That will be a big number to display. So I have given input 5 and I am just printing to demonstrate the loop by decrementing the number. There's not much change in the while loop, but in the for loop, as you can see on the right hand side, I have written some statements about the for loop. Traditional for loop that we used in Java, which is something like this, is not possible in Python. So here in Python we have two different structures to use. One is this for I in. In is a membership operator which denotes that a given value is present inside the list given or not. So this only works with string and list. It does not work with integers as the value is considered as a whole and we cannot traverse a single value in integers. So we use a different structure for int values. This also supports other data types as well. So for the other structure, there is a range function which we use. Start index is optional parameter, which the default index starts with 0, and if you want to start a different index, you can just put it here, and the end index has to be given for the loop. And steps are just how many steps you want to carry out in the loop. Like if we give a start index of 0 and end index of 10 and steps of 2, then the loop will be only executed 5 times. As I said, start index and steps are optional. Only end index is mandatory, and which has to be given as you see here. So I'll just run the code again for loop. So that's it for the episode 2 of Python Basics. We'll be covering classes and functions in the next video. Hope you like this video and consider subscribing if you haven't already.